We'll go live, Kiran. Good afternoon, friends. It's my pleasure and privilege to welcome you all for this ninth distinguished lecture series on energy efficiency. This is one which we have started some time back to bring you some thought leaders on energy efficiency, to share with you their views and also answer some of your clarifications. We are privileged to have Dr. Jairam Varadaraj, Managing Director of LG Equipments Limited, to be here with us and deliver the distinguished lecture today. Dr. Jairam Varadaraj is the Managing Director of LG Equipment Limited, and he has transformed a family company at the national level into a global organization. Currently, LG is number 7 globally in terms of the compressed air business. The LG is working under the leadership of Dr. Jairam Varadaraj in becoming number 2 globally in compressed air business by the year 2027. Under his leadership, LG has expanded both geographically as well as in different sectors. It's prevalent in many countries in Middle East, Europe, and USA, and also expanded into sectors such as textile, polymer, mechanical equipments, and consumer appliances. Dr. Jairam Varadaraj has a unique leadership methodology. He works towards both manufacturing excellence as well as corporate social responsibility. He considers both of them to be symbiotic to the growth of the organization as well as the country. Dr. Jairam Varadaraj happens to be an alumni of George Washington University and University of Michigan. Having said that, Dr. Jairam Varadaraj has several achievements and contributions to his credit. Under his leadership, LG has won the Deming Prize for Manufacturing Excellence and TQM initiative in 2019, the coveted Deming Prize. The first time a compressed air company could win this prize outside of Japan in the last 60 years or so. Dr. Jairam Varadaraj has been very passionate about innovation which is breakthrough as well as frugal in nature. He is one of the most sought after businessmen for being part of the directorship of several companies as well as non-profit organizations. He has also been very actively involved in CII. He has been the past chairman of CII Tamil Nadu and also a member of CII Southern Region. A very strong technocrat, Dr. Jairam Varadaraj owns 4 patents in the fields of food processing, bells, compressors, and consumer appliances. We are privileged to have you, sir. And without much further ado, I leave the stage to Dr. Jairam Varadaraj. Dr. Jairam Varadaraj.
Thank you very much, Mr. Venkatagiri. Thank you for having me over this evening on this very prestigious platform to talk about energy and its consequences to the world. I'd like to thank everyone who are participating in this webinar. I hope everyone and their family is safe as we together fight through this rather difficult times. And I think as a country, we should be very proud. I think we have done a phenomenal job as individual citizens of this nation in keeping this at bay the way we have done. So something that all of us can be very proud of. Now, I'm not a big expert on energy, but we are in a business that makes machines that are not the most energy efficient. Compressed air as a utility is not a very efficient utility. And by virtue of that and making compressors, there is an acute sense of energy, I would call it stinginess in our company. We want to be as stingy as possible in the machines that we build, not only in their footprint of efficiency, but the energy that we use to actually make the machines. But when you talk about energy, I think there is a general tendency to kind of let the mind veer towards electricity, right? But I think energy is a much larger animal, right? The energy is just at a very theoretical level is the capacity to do work, right? But it's a very, very large envelope. And electricity, for many of you may know, is only 19% of the total energy of this world, right? If you look at the energy that is burnt to produce all the forms of energy, electricity produced is only 19% of that. Thermal, which is used in cars, in processing, in heating, and in cooling, is another big user of energy. Thermal energy is a big form of energy that is used by this earth. As you and I, as human beings, we do a lot of that, right? And this larger definition of energy also includes very critical dimensions of water, things like water, where energy is used to deliver certain aspects of water. So, and this energy is a very, very big number, right? If you use the current price of electricity, average price of electricity between industry and households in India at 7 rupees per kilowatt hour, the global value of energy is between 15 to 16 trillion dollars. That's the size of the energy that gets consumed in the process of creating energy, right? And the unfortunate part of that is only 30 to 40% of this 15 to 16 trillion dollars is actually put to use. The rest of it either goes in various forms of waste in the process of production of energy, in the process of transmission of energy, and the process of actually using the energy to get work done. So it's a very, very big cost. And it is and you look at most of our businesses, energy, we tend to measure energy only in electricity. But if you go back and look at measurement of your energy in your business, the consumption of energy in your business, it's a pretty significant number. You know, a lot of us look at some businesses have very low, like 2% or 3% of their revenue is energy and electricity. And they tend to think that, oh, my business has very low energy footprint. But in reality, we have really not measured the entire energy footprint of our businesses. And if we do, we'll be quite surprised that a large percentage of our revenue is used up in consuming a lot of energy. And you look at our own, as individuals, you look at our own household bills. Progressively, as we are going up the scale in our standard of living, our own electricity bills are progressively going, and we forget that we also have other forms of consumption of energy. We tend to look at energy only through the lens of electricity bill. But as individuals, if you step back and look at all the energy that you consume and the cost of that energy, it's a pretty significant number, right? So both from a business point of view and as individuals, there is a tremendous economic sense to look at energy as a unit of consumption that needs to be very tightly managed from a cost point of view. Now, as a country and as Indians, our per capita consumption of energy is 90% lower than what the per capita is in the US and 80% lower than what it is in China. Now, as we aspire to grow as a nation, our standard of living, a quality of life, this per capita consumption of energy is going to keep going up. And therefore, there is a need for us to be extremely cautious and careful in terms of how we control the consumption of energy. Now, that is on the economic side. You know, the economics of energy, the cost as it impacts our business, the cost as it impacts us as individuals. But there is a huge environmental impact on this almost frivolous path that we have gone over the last probably 100 years in terms of how we have consumed energy and taken it for granted. The consequences to the environment are, I mean, I don't have to come onto this platform and talk about it. There are health benefits to each of us, health benefits for our children, and definitely health benefits for the future health consequences for the future generation. And this is something that we have taken this world over the last 100 years through our frivolous consumption of energy and various forms of energy. We have brought it to this level. And now there is a responsibility for us to clean it up and leave a better world for the future generation. And the good thing is this is possible, right? And it's not reached a point of no return. It is still doable. The earth has an extremely good way of healing itself, provided we allow it to heal, right? And it is possible. And we have seen it in the months of April and May. You look at just when the earth world came to a pause and a standstill, the way in which nature transformed itself and healed itself. We have seen so many examples that have been shared by people from all over the world of how pollutions have vanished, wildlife has returned, in so many instances. So it's a very positive thing, very optimistic platform in which we are working on, but we have a responsibility to contribute by being more responsible about the way we consume energy and the way we produce it, right? Now, there is a tendency that there is fossil fuel, which is the brown fuel that is causing a lot of the environmental issues. Then there is a move towards renewables, whether it is solar or whether it is wind. There's a big move, and the world has done a big shift. I mean, nowhere close to what is required. Still, fossil fuel is close to 80+% of the total energy that is produced in this world. And solar has come a long way, and it's around anywhere between 12 to 15%, in some countries even higher than that. But irrespective of how the energy is generated, I think it's important for us to look at consumption. Now, let us not take something that is abundant and we think it is cheap and clean, whether it is solar or whether it is wind, and consume it, continue to consume it in a very frivolous manner without taking cognizance of where we can conserve energy, how is it that we can explore various technologies and possibilities to conserve energy. Let me tell you, I mean, we talk about solar. You look at the amount of land that is required for setting up solar. It's a huge amount of land. And solar photovoltaic cells have an expiry date. So what's going to happen to those cells? They become e-waste. Are we going to then move from one level of environmental chaos to another level of environmental chaos? So it's important for us that irrespective of how we generate, how cleanly we generate energy, the conservation and very, very judicious use of energy is very important for the future of this earth. Now, the health of the planet is very critical for us in terms of how we behave and our responsibility. And we cannot be selfish about this. And as we go forward, we need to look at these aspects of it deeply. Now, there are multiple levels through which energy savings, reduction in energy consumption, optimization of energy can happen. One is obviously at a policy level by the government, where they induce or encourage certain types of behavior and they penalize certain other types of behavior so that the generation of electricity is clean and the consumption of electricity is prudent. Or I keep saying electricity, that you can imagine how all of us are conditioned to think energy is electricity. But energy I'm talking about, the right kind of energy production and the right prudent form of energy consumption. The second is the legal layer of actually legislating certain things that will prohibit certain practices. The third, which is most important, and I think this is where the biggest change is going to come, is our own behavior as individuals, where we and manage businesses, as well as people who are professionals playing various areas. Look around us, there is always opportunities for us to save energy, whether it is motion sensors for activating lights or fans or air conditioning, whether it is looking at measurements of electricity consumption per unit of your output, doing a detailed analysis of which are the contributing factors, which are the machines and the utilities that contribute to your the footprint of the production of your production first. And every machine or every output that you do has an energy output. Now, can you look at measure those energy profile of your product and say what is it that you can do to bring that energy profile, make it lighter, make it smaller. And it's a constant opportunity. In our own company, we have, as our power consumption, in spite of close to 30-40% growth, our electricity consumption, I wouldn't say energy, electricity consumption has been flat for the last probably 5 to 6 years, right? Now, this is not by accident. We have a team of people, extremely enthusiastic set of people who take it as a life mission. This cannot be done by setting KRAs for people. A KRA is a mercenary contract, right? Energy consumption has to be managed by a deep emotional connect that we all should develop, the responsibility that we have to leave a healthy planet for the next generation. So this is not about KRAs. This is not about gold sheets. This is about fundamentally, as human beings, our responsibility to the earth that we live in. This is not about responsibility to the company or to your manager. It's your responsibility to the earth that you live in. And you look around you, there are opportunities every day for you to improve. And that's the best part. This is not very difficult to do. It is very easy to do. It just requires consciousness. It requires a certain level of commitment. And we will definitely, this can happen. So these are some of my thoughts and upper level, kind of emotions that I wanted to share with you. I'll be very happy to take questions and clarify for some of the thoughts that I mentioned. Thank you very much again for having me. I wish that every one of you take it upon yourself that energy consumption is a responsibility that all of us have. It's not about companies, it's about us as individuals. And if we take that up seriously, we can leave behind a very healthy planet for the future generation. Thank you.
Thanks, Dr. Jairam. Thanks for your address. I think a few questions that have started coming in is more on compressors, probably because a lot of people were expecting a few more inputs from your side on air compressors, but nevertheless, I'll run through the questions so that we could have your inputs and thoughts on those.
Absolutely.
But before we go ahead, sir, you touched upon the policy, the legal, and the behavioral aspects on energy efficiency that would be required in terms of making a change. What do you think we as a country need to look at? I mean, are there any specific areas that you think more actions are required? Are there any areas that we should be acting more than what we are doing currently? Any thoughts on what next is required at the national level?
I think on the generation side, how to create clean energy, I think there's a lot of consciousness at the government level. There is a significant amount of promotion of renewables as a increasing source of our energy. So that's in the right direction. But I think what is required is, renewables by virtue of their nature are variable power. They are not on-demand power, right? So to create the right kind of storage, today the storage solutions are only in batteries, right? Hydrogen as a possible storage option is emerging in a lot of countries, but hydrogen compared to battery is still very expensive as a form of storage and in the energy value chain, right? So, but nevertheless, that is the future reality, whether it is batteries or whether it is hydrogen. I think there should be at a policy level significant investment for India to get ahead of the world in terms of these two technologies. We are probably a little behind, but it's not too late. If we can create we can bring together the right policy mechanisms and the organizations to work together, investment in solutions be a big game changer for the future. So that's more on the generation side. On the use side, I think there has to be a greater marketing propagation of consciousness at every level of consumption, and some sort of a basis. I don't think people, if you tell them consume less energy, I don't think they will say, no, I want to do more, right? If they are able to, if they are given the tools to make the right choice, whether it is the efficiency rating of appliances, efficiency rating of machinery, efficiency rating of food, for instance, every product, if there is an efficiency rating as far as its energy footprint, and then there is a propaganda for people to become more and more conscious, the whole ecosystem will then start getting sensitized to the need to be more energy thrifty, and therefore everyone contributes.
Thank you, sir. You spoke about the varying generation from renewable energy sources, and one of the sources of energy storage, which has been discussed for quite at length, has been the compressed air as a means of energy storage.
Yeah.
What are your thoughts on that, sir? How close are we to look at compressed air as an energy storage option?
It is an option. Technically, it is feasible. But if I have to compare it with other forms of storage, whether it's a battery or whether it is hydrogen, it's not as friendly as these two options, right? First of all, in order for you to recover the energy from compressed air, you need to store the heat that is generated by compression, right? And that heat has to be injected back during the expansion cycle, right? Now, all this is pretty complicated, right? The storage of heat without any deterioration of the heat content is not very easy. And when you're compressing air, you need huge amounts of space to store that air. So they're looking at old salt mines and deserted underground mines, but the access to them is not very close to where the demand is, right? So if the demand is in the city, you can't have a generation source that is very far away, and then there are losses, right? So it is source, but I don't think it is a very efficient source. So there could be specific applications wherein it could be used.
Thank you. Okay, the next set of questions were in terms of access to finance, Dr. Jairam. I mean, energy efficiency, when we speak about it, definitely it calls for investments, and access to finance becomes one of the key enablers, particularly in countries wherever energy efficiency is accelerated significantly. One of the major lever has been making access to finance much more easier. I mean, what are your thoughts in terms of how could finance be made more accessible for industries who are looking at energy efficiency, and particularly in this post-lockdown era when cash is one of the scarce commodities and industries are trying to preserve it as much as possible? What are your thoughts on how access to finance may be made available for energy efficiency?
I think financial intermediation that considers cleanness of the investment, right? Environmental cleanness of the investment, which also includes energy saving, right? Really changes behavior, right? Now, if you look at countries like in Germany, many of the lending is banned for certain sectors, right? Those are considered as the unclean, dirty sectors. It is banned, right? You don't lend. Now, we haven't reached that level of rigidity, but the more and more policy comes in favor of clean energy and efficiency, then there will be a shift in behavior after financial intermediation, and therefore there will be a shift in the final users. But you were saying that there are constraints during this pandemic. I actually think that this pandemic has created a lot of cash in everyone's pocket. Companies are actually financially healthier now than they were before the pandemic, which is a little strange, but seems to be the fact. Yeah.
Thank you. Thanks, sir. Sir, there are quite a lot of questions on air compressors and efficiency in air compressors. You talked about renewables. One of the questions that has come up is in terms of, can renewables be used for driving compressors directly? Today we have steam-driven compressors, we have other utility-driven compressors. Tomorrow, could there be a situation where a compressor can be driven directly by a renewable energy source, maybe wind or solar? Is that possible?
Absolutely. I mean, absolutely, it's possible. I mean, you can even drive a compressor with a windmill without even a motor, right? Directly. And we did, in fact, as an experimental opportunity, we did make a product as a prototype many years ago. But it's as a technology, it's great to showcase it. But from a practical use point of view, it will not, because industrial power is a very fluctuating power demand in most, except in process industry. In most other industries, industrial energy requirement is very highly fluctuating. It changes, the baseline changes from first shift to second shift to third shift. So your source of energy should be extremely flexible to deal with that, right? So if you have a renewable energy driving a compressor, you will have that patchiness, in terms of the variability. So you need something as an intermediary agglomerator of energy to drive the compressor the way you want. But it's possible, technically possible, practically not feasible.
Sir, in the entire compressor system, you started your talk by saying this is one of the inefficient systems in the market. We still see a lot of opportunities that still exist, both in the generation, in the distribution, and in the use of compressed air systems.
Yeah.
Particularly in the small and medium enterprises, where the potential for saving generally is much more larger.
Yeah.
What are your thoughts on how can we look at improving the efficiency of the overall system? Is it a question of technology? Is it a question of awareness? Is it the seriousness that needs to be brought into this utility? How can we look at improving the compressed air efficiency as a whole?
Yeah. So there's a multiple levels that we need to deal with. Fundamentally, I think a lot of our customers think that compressed air is free. They bought the compressor, they switch it on and they run it, and it produces air. It produces something as simple as air, as friendly as air, as something as soft as air, right? So it tends to make people think that it's a very nice thing. It's not very efficient, right? But it's super inefficient, right? Because only 30% of the energy input you're getting work. And like you go to many factories, people use compressed air to clean their uniform, their shoes, their cycle, the motorbike. It's the most inefficient thing that you can do, right? But it's the easiest thing to do, right? So first, awareness that this is an extremely expensive commodity has to be first realized, right? That's fundamental. The second thing is, in our experience as a compressor manufacturer, we do a lot of audits for our customers. The largest inefficiency is in the compressed air pipeline. Yeah? Typically, we find that 20 to 30% losses are there because of leaks in the pipeline, right? Now, customers tend to buy they're very judicious in their choice of compressor. They buy a compressor which is very efficient, but then they compromise on the choice of the piping, right? Whether it is the material that is used in the piping, the fittings that are there, the tightness of the fitting, the firmness of the fittings, they compromise there. And as a consequence, 20 to 30% of your energy is lost through leakages in the pipe, right? And you got to understand the piping is constantly in vibration because air is going through and there is a fluctuating air demand. The pipe is under vibration, and when it is under vibration, you need to constantly maintain it because one-time tightening is not good enough. you need to maintain your piping system periodically. So constant observation of leaks and fixing is a huge amount of thing. The third is, of course, you need to buy the right compressor. Of course, you buy an LG compressor, you will never make a mistake. That's for sure. But that apart, I think the choice of the compressor in terms of the configuration is very important, right? If you have a fluctuating head on and you buy a fixed speed machine, there are penalties because every time the compressor unloads, there will be, the unload power, which doesn't, you pay for it and you don't get any energy from it, right? So looking at, variable control systems, variable frequency drives, there are many methods of controlling it. So investing in those is very important too. So there are multiple ways of doing it.
Thanks, sir. I think the next set of question was in terms of the purchase of compressor, and you rightly touched upon that area. Usually what happens is in compressors, the buyer, the client, the user, these are all three different people. The buyer is usually somebody from the purchase team typically, the client has got some other requirements, the user has got a different requirement. So what kind of, inputs would you think is appropriate at that stage where they're making a decision of going for the most efficient unit? Because that to a large extent determines the entire life cycle performance of that equipment, sir.
Yeah. So if you look at the life cycle cost of a compressor on average, close to 70% is energy cost, about 10% is the upfront cost, and about 20% is the maintenance cost. These are rough numbers. It varies here in that neighborhood. So you have two customers who look at two different aspects of this pipe, life cycle pipe, right? The purchase department will look at 10% of the life cycle pipe. The maintenance department will look at 90% of the life cycle pipe. Unfortunately, the 10% pie will make the decision, and the 90% pie has to take responsibility for that, right? If there is a way by which we can convince the 10% materials department, which is making the decision, to understand the consequences of 90%, because in most compressors, right, 1% is a significant savings in power, right? You can, if you look at just the pressure, 1 bar of pressure, right, is close to 10% of the power, right? And if you just save that 1 bar of pressure and you buy the right compressor, maybe a little bit more expensive, you buy the right compressor, you'll get that difference back in about 3 to 4 months' time, right? So it is understanding the numbers, because a lot of people think compressed air is not, it's okay, buy the cheapest compressor, let it run. What are you worried about? And I think it's important, the buying price is the least expensive, right? It's the running cost and the energy cost of that is the most expensive. And they need to become more aware of that.
Thank you, sir. Thank you. While on one side, the choice of compressor or the decision that they take during the purchase is a critical aspect, another major determining factor is the end use application. And be it bag filters for cleaning, or be it instrumentation requirements, or be it grinders or nut runners or the assembly line devices. What do you think, sir, we should, as collectively, people in this market do in terms of looking at the end use efficiency, both in terms of the consumption or in terms of the requirements of compressed air? What kind of viewpoint they're looking at, what kind of pressure requirements they're looking at, and is there a possibility of optimizing that so that the overall generation and the system becomes more efficient?
No, I think it's a very valid point. On the demand side management of compressed air efficiency, the number one criteria is pressure management. Typically when there is a pneumatic device, the designer of the pneumatic device will add a certain buffer of pressure to the design pressure, right? That pneumatic device goes into another machine, and the machine designer will add another layer of buffer to the pressure requirement. The machine is bought by the customer, and the customer adds one more layer of buffer to the. So there are 3 layers of buffers that are there in the pressure setting of any machine, right? Now, then nothing was going to happen if you under pressurize your machine, right? because pressure is rate of work, right? Flow is the work done. Yeah? So as long as your flow is there, you keep playing with the pressure. For the right pressure, you will know what is the rate of work that you want, right? And you can set your pressure to that, irrespective of who recommends the pressure, the machine builder, or it's your choice. There's nothing is going to happen to the machine, nothing is going to happen to the system, right? So, in our opinion, typically there is at least 1 to 2 bar of savings in any installation where you can bring that down. That's anywhere between 10 to 20% of the parent horsepower of the compressor, right? That's a lot of money, right? The second aspect of it is you're looking at your cycling. Yeah, the demand cycling is always there, right? And you will have different processes requiring different pressures, right? Customers tend to buy a compressor with the highest pressure, right? You should not do that. You should not buy the highest pressure. Look at multiple lines if the volume is very high, or look at simple boosters that will take your pressure up only for that requirement, right? Those are huge savings that you will gain from it. So these are two things that we have seen play a big role in bringing the power down, energy consumption.
Thank you, sir. Thank you. Earlier, when we are involved in the efficiency studies, sir, earlier the older generation used to be only the compressors and the user, but today we have a whole lot of intermediary steps which are coming in. You have the controllers, you have the efficient filters which have come in, the dryers are becoming more and more efficient. What role do you think this entire downstream equipment play in the compressor system, and what can be done as a improvement in the overall system, sir? Are there any other better ways of handling it? Do you have any suggestions on how that could be managed better and efficient?
Yeah, I see the downstream equipment from the compressor is a function of the process that is required, right? So some processes need dry air, and they need clean air, right? That a lot of tendency is for customers to either downsize the filter or to downsize the dryer, right? Now, when you do that, there are huge losses that go through that system, right? So you're better off oversizing your downstream filters and your dryers so that your pressure drop in your system after the compressor to the end application is significantly reduced, right? So in the interest of saving capital or interest in saving the cost of the filter, people tend to downsize it, and as a consequence, what happens is there is a continuing penalty on the energy that is consumed by the compressor because of pressure drops in the system, right? So this is something that we need to look at, right? There are so many variables. I can't prescribe one solution, but generally what we find is tendency to downsize, and therefore there is a penalty on it. Yeah.
Sure, sir. Now, you rightly mentioned, sir. I mean, there are various parameters which determine the purchase and selection of these equipment. Now, unfortunately, in India we still don't have a program like the CAGI or the in Europe or other programs which are running in other countries globally, which CAGI and the Compressor Challenge have been doing phenomenally good work in the US. Europe has been doing a lot of work in the European region in terms of standardization, in terms of awareness, in terms of capacity building. You, of course, being an international player, sir, your compressors would be exposed to these requirements globally.
Yes.
But we do not have one such a kind of a driver program in the country here. So what do you think would be the need for such a program, sir? And where do you think such a program can build or add value into the whole ecosystem?
I think it's absolutely critical. I mean, we are members of the CAGI verification program. You go to the CAGI website, you will see our compressors tested independently and the results published. We are also aware of Lot 31 in Europe, which specifies without Lot 31, you're not even allowed to sell. And all our compressors are above the Lot 31 standard, far better than that. So every country needs that kind of a energy standard, because especially because compressed air, if you look at it, consumes close to 10% of the industrial power worldwide, right? And therefore, it is important that customers make a very informed decision about the machine that they're buying in terms of the consumption. Now, the government of India has already started with the Bureau of Indian Standards. They have put together a committee and they are evaluating efficiency standards for rating. So tomorrow, all the compressor manufacturers, based on their performance, which will be tested in a laboratory and then rated, they will get different star ratings, similar to what is there in some of the air conditioners and refrigerators. The same thing is going to come, which is a good step forward.
Sir, my next set of questions that I see are on automation and the digital transformation that is happening in this. Today, the systems are, I mean, we have flow meters coming in, we have energy meters coming in, we have more number of pressure sensors coming in to give a real-time feel of what is happening. I think we have come to a certain level of maturity, at least in the larger industries, in industries who are aware of the use of these digital interventions. But a large majority of the equipment is still not having any of these systems. How important do you think is the intervention of automation and the digital controls as an enabler in the efficiency improvement of compressed air system? That is one in terms of the older stock. The second question is, where do you see the future of it coming in? I mean, do we see any trends in terms of that be a major player in terms of improving the overall system efficiency?
Absolutely. So, on the existing install base, the more you know, the more effective your solutions can be in terms of configuring your compressor, in terms of either sequencing or looking at variable frequency drives, or reconfiguring your compressed air system. The more information you have, the more robust your decisions are. But unfortunately, at this point in time, sensors are expensive. Right? They are not, they're quite expensive. Prices are coming down and we are looking at it, which segues into my second conversation. In the future, we will be looking at more and more sensing capability, not only in the compressor, but in the whole compressed air system, and be able to advise the customer on a real-time basis. What is wrong with their configuration? What can they do to fine-tune and get those benefits, right? We already have some algorithms. We have our own IoT device that we put on our machine. In April next year, we are doing a global launch of it. But we have tested that and we have found extremely good savings for customers, even with the limited amount of sensing that we are doing, right? But we are hoping that sensor prices come down, whether it's flow sensors, temperature, power, pressure sensors, all that, the prices come down. So we have multiple degrees of freedom of measurement, and then therefore we are able to give more coherent advice to our customers.
Thanks, sir. Now we see all the utilities gradually shifting towards being utility as a service, sir. We see, electricity was always a service. Now we see steam as a service. We see cooling as a service coming in. Will we see compressed air also becoming being supplied to the industry as a service rather than selling compressors? Do you think that kind of a day will come? One, for large industries, sir, and second, the small and medium enterprises are located in large number of clusters. And the efficiencies of these smaller equipment in multiple small and medium enterprises in a cluster is definitely inefficient. Do you see a need in such clusters or in such large organizations where compressed air may tomorrow become a service? And would a player like LG, sir, would you be interested in is that a model that is in your radar? Is that also something you're considering?
So compressed air as a service is not something new. It's been around for a long time. But when your air demand is not very high, and if your air demand is not very constant, right? it becomes very difficult both for the provider of that air and for the consumer of the air to agree on a pricing model which makes sense for both, right? Because as a provider of machinery, I've sunk my cost in, right? So I need a constant air demand or sales of air. Whereas for the customer who has very fluctuating air demand, he doesn't want to pay for the constant air. So this is like, some of the solar rooftops, right? That they want to install in factories. When the factory has very volatile and electricity demand, whereas the solar installer needs a certain constant revenue, right? And there is a lack of parity there. So that's a problem area that needs to get resolved, right? That's one. Volume is very important. So if you look at blast furnaces in a steel factory, the oxygen is supplied on that principle, right? These large gas companies actually set up their plant next to the steel plants and supply oxygen for the steel blast furnaces. A huge volume of air and it's constant. So there is a value proposition for both, right? So it is possible, but it needs to, volume is important, constancy of demand is important.
Thank you, Doctor. Now, the next set of questions are around benchmarks, sir. Now, for all the utilities today, we have certain benchmarks in terms of the generation efficiency and the consumption rate in various sectors. Do you think such benchmarks exist for compressed air in various sectors, like, for example, say textiles or foundry or some of the large process industries? Is there a need for driving efficiency through benchmarks in the country? Do we see that as a means of driving efficiency?
It's possible, Anand, but the point here is when you set a standard, right? When you set a benchmark, the conditions should be standard across, right? Then the benchmark becomes relevant, right? So that is the difficulty, right? So when you look at, let's say, a spinning unit, right? A textile spinning unit, if their configuration is identical in terms of what kind of count they're spinning, their blow room specification, their simplex, their ring frames, their autoconers, if all of that is synchronized, standardized, then you can have so many units per grams of, so many CFM per gram of cotton or something of that nature that you can do. But when you don't have that, what we have seen is a lot of our customers create their own internal benchmark and say, this is our starting point. We want to reduce it by 20%. And then they go through that and then they say, okay, another 20%, right? So some of our cement customers, some of them claim that their total energy cost per ton of cement is the lowest in the world. And they say that some of our compressors have contributed to it, right? To that reduction. So, but it's not a benchmark that can be applied, unfortunately.
The next is on compressor technology itself, sir. We know of the three classic technologies or the types of compressors which are being used. Are there any developments? Are there any innovations coming in these three types, or is there any new type of compressor which is going to be coming up in future, which will be significantly transformative than the rest? Is there anything happening on the compressor technology itself, sir, globally?
The fundamental principles of compression remain the same at a very generic level. The most popular is the piston, the screw, and the centrifugal. These are the three most popular compression mechanisms for compressing air, right? There is a little bit of scroll activity, but very small, right? So there is no new mechanism that has emerged in terms of the method of compression. But there is a lot of work being done on efficiency of the compression process, right? So, like I said, only 30% of the energy is used as work that is available that can be done. Quite a bit of heat. I mean, almost 100% of the the kilowatt of the motor is generated as heat. Now, recovering of that heat, reusing of that heat, these are all methods that systems are being done to increase the efficiency of the overall system. Rather than, there's no big breakthrough in the compression methodology itself, right? We have recently a compressor that is injected with water, and the primary reason is by injecting it with water, you reduce the heat of compression. So when you are compressing air under low temperature conditions, the efficiencies are high.
Thank you, sir. Thank you. Now, I have a couple of questions. One question is on the capacity building at the various user segments. I mean, as we discussed, there is a lot of maybe lack of awareness or lack of motivation in terms of both the users and the consultants and other players who are working on this area. Do you think is there a need for something like a nationwide program that can be run for creating more awareness, more case studies, more thoughts, more action on efficiency improvement in this area, sir? I mean, any thought on capacity building as a thematic area for efficiency improvement in this utility?
So, as part of building the overall awareness of the energy footprint of compressors to customers, so that they don't take the energy part, which is 70% of the life cycle cost. They take that very seriously in their purchase decision. The second aspect that they need to take very seriously is the sizing of the compressor, right? People, like when I'm buying a machine tool, right? Let's say I'm buying a machine tool, I need a 500 millimeter admit, right? I may buy a 750, right? It doesn't change it doesn't make my 500 requirement inefficient. But if you take a compressor and make 50% more, you buy a higher capacity, the efficiency losses are phenomenal, right? So it is very important that you do not oversize the compressor, thinking that I will grow with it, right? But if you want to do that, if you want to really protect your investment for future, there are technologies and solutions. You need to invest in those, whether it's a variable speed run, whether it's a different kind of valving system, different kind of heat recovery system. You need to put that as an envelope. Then you invest in a larger size machine, you're okay. But on a fixed speed machine, if you do double your capacity to protect your future growth, it's a very inexpensive, very expensive, inefficient way of building capacity.
Thank you, sir. That was on the capacity building, and now the other part is the old stock of compressors which are remaining. And fortunately or unfortunately, sir, this is one equipment which has got a very long lifetime. I mean, compressors which are even more than 15 or 20 years old or 30 years old are still running in the industry and delivering share. Unlike lighting or other systems which has got a natural replacement rate. Given that scenario, sir, do you think is it also time that we looked at a country level a compressor replacement program, particularly for the inefficient ones, alongside creating awareness? Also talk about a replacement program which motivates many other players to come forward and start looking at replacement as one of the big changes as far as efficiency improvement is concerned.
I don't know whether legislate a compulsion, Mr. Anand. That's not possible. We have not seen that kind of legislation anywhere in the world. But there is a lot of incentive, right? Like for instance, in California, you cannot buy a compressor which is other than variable speed above a certain kilowatt, right? And there are in Europe, if you buy a variable speed machine, there is incentives that you get from the electricity company, right? So you can create an incentive-based system for people to change over their compressed air system. But I can tell you, many of our compressors, we have multiple generations of our machines. Now, our oldest generation to the latest generation is an efficiency gain of 8 to 9%, right? And a lot of our customers are actually replacing their old machines with a new machine. Not as fast as we would like them to be, but they do. Yeah.
Thank you, sir. Thank you. I think these were the set of questions that we had for today. Of course, there is just one last question that has come in there for the benefit. I'll take it because that is interesting. While you mentioned that we cannot regulate the replacement of compressors, so the question is, can we have a regulation banning the use of inefficient ways in which compressed air is being used, like cleaning or vibration or agitation? Is that something there where a regulation can come in? That's an interesting question that just came up.
Well, you can legislate things. The point here is, at the end of the day, if the owner of the business realizes that they're blowing money through that air that they're using to wash themselves, if that realization is not there, legislation, you can't have a police sitting there watching a factory all the time, right? Now, the fundamental thing is consciousness, right? And it is cost. There is significant amount of cost and environmental damage, right, by doing this. So if we can bring that consciousness in, we'd have made a big difference.
Thank you, sir. Thank you for your address. Thanks for patiently answering all the questions that came up. I think we had a very interesting session so far. Maybe I can just let you have the last couple of minutes, sir, to share your thoughts in closing, and with that, we can close the session for the day.
Sure. So I thank you again for all very interesting questions. I apologize that I did not talk much about compressors in my regular address, because I felt that it would be not right on my part to come and talk about compressors. I thought I'll just wear the LG shirt and leave it at that, rather than talk more about our products, and I thought it would be unfair. So that's the reason why I did not talk too much about compressed air when I spoke. But the questions have been very interesting, thought-provoking. I hope that my responses are very useful, and I'm quite happy if such of those questions that I've not addressed or not been able to address a paucity of time, I'm quite happy if you can forward it to us. We will reach out to our people, to each of those people, and we will provide the most honest answer that's possible.
Thanks a lot, sir. Thank you. Thank you for your participation in the session. Thanks for your address and for all the questions that followed. Thanks a lot. To all the participants, thank you for joining. It has been a pleasure listening to Dr. Jairam and answering many of the questions that you all had. Thanks a lot. And with this, we close this Distinguished Lecture Series session. Look forward to having you in all our forthcoming sessions in future. Thanks a lot again. Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you. Thank you.